We are given here with circle A, and we are asked to solve the measurement of the variables x, y, and z. To solve for the three variables, we need to understand what are they representing so that we could draw relationships as to the given measurements on the same given circle A. When you look at the three angles, we have here angle x, or three angles here which are represented by the variables. You have here for this x, this angle for y, and this is for the angle for z. None of them are considered to be central angles. None of them are also considered as inscribed angles. If we talk about central angles, the angles or the vertex of the angle must be at the center, and its sides should be radii. But none of them has their vertex here. Also, they are not considered as inscribed because for them to be called inscribed, the vertex should be placed on the circle and the sides should be chords. So we cannot use the relationship of the central angle as to its intercepted arc, which is just the same measurement, nor the relationship between the inscribed angle and its intercepted arc, being the measurement of the inscribed angle is half its intercepted arc, because, again, the three of them are neither central angles nor inscribed angles. So what we could do here is simply look into the relationship that these three angles here are angles formed when two chords intersect inside a circle and the point of intersection is not in the center. We actually have theorem for this to support the measurement of each. Let's look into the measurement of angle x first. For any angle that is formed by two intersecting chords, we can actually draw that the measurement of that angle, let's say x, is actually the average of its intercepted arc and the arc intercepted by its vertical angle. Again, let me repeat. The measurement of an angle formed by two chords is equal to the average of its intercepted arc and the intercepted arc of its vertical angle. In this case, we could say that's when you say average, so it means we are going to add and divide them into two, or simply use the term 1/2. The sum of its intercepted arc, 145 degrees, and the intercepted arc of its vertical angle y, which is 55 degrees. This is how we solve, again, the measurement of an angle which is formed by intersecting chords. So the measurement of angle x will be solved in this manner. 1/2, the sum of the two arcs is 200 degrees. Therefore, the measurement of angle x is half of 200, which is given to be 100 degrees. This is how we solve the measurement of angle x. For angle y, since y is also with the same concept as angle x, so we could also draw that this is half, or the average of the sum, or half of the sum, or the average rather, of its intercepted arc, which is 55 degrees, and the intercepted arc of its vertical angle rather. So it will follow the same process. But of course, you can just simply use the relationship of vertical angles, because we have vertical angle theorem, which states that the vertical angles are congruent. So the measurement of angle y is just the same as the measurement of its vertical angle x. So the measurement of angle y is equal to the same value of 100 degrees. But of course, if you would like to, you could just check it using this formula. You change this to y, and you simply add the same measurement of arcs, and you will still get 100 degrees. So two unknown measurements are now given. For the measurement of angle Z, since it is the same with X and Y, you could also use the same concept. Okay? Of course, the circumference of the circle is 360 degrees, and the sum of the given arcs is 200 degrees. We could say that whatever is the measurement of this arc intercepted by arc Z and the arc opposite it or its vertical angle, their sum must be the remaining 160 degrees, and when divided by 2, you will get a result of Z equal to 80 degrees. 80 degrees. That's another thing. But of course, if you are not sure with whatever computations you have, and since there are no given here, you can just simply use the concept of the linear pair. Since angle X and angle Z forms a linear pair, we could say that the measurement of angle Z plus the measurement of angle X is equal to 180 degrees, because our angles forming a linear pair are supplementary. Since we already have the measurement of angle X, the measurement of angle Z plus X, which is 100 degrees, is equal to 180 degrees. And by the subtraction property of equality, the measurement of angle Z, simply using the concept of linear pair postulate, is equal to 80. That's 80 degrees. So this is how we solve the measurements of X, Y, and Z being angles formed when chords intersect, being half of the average of the intercepted arc and the arc intercepted by its vertical angle. This is how we solve these unknown measurements for this given circle A.